Okay, here's your first reminder for tonight. I'll write them again. Last time I'll write them. Follow instructions. In addition to all the other class rules, these are the ones that people keep missing. Follow instructions. Emails about labs or assignments are not answered. You have to figure it out and ask me in class before the lab is due. That's why we have lab time. Follow coding standards. That's part of follow instructions. 1998, there was a movie called Armageddon. Anybody ever see it? By today's CGI standards, it would be fairly marginal, but whatever. Okay. Today, Monday, yes, Monday, 2022, there was a mission called DART. Anyone know what DART means?
Is that like double asteroid redirection test?
That's exactly correct. Double asteroid redirection test. They find out what they're going to do, then they fit an acronym to it. That's what they typically do. There's a point to all this. There's a point to every story I tell you if you, the global you, but have the wit to see it or the wit to ask. Okay? That's a life lesson, or it tells you something about coming up in your future as a IT professional. 7 million miles from Earth, there was an asteroid. We'll just call it like that. We all know what my art skills are. And this asteroid is circled by a smaller asteroid, not to scale, by the way. And they have some names, Dimorphos, and I forgot the names, right? Some Greek names or something, right? But the point is, you have one asteroid being orbited by another asteroid. This asteroid here that's circling it, the period and trajectory of this can be well established with our measuring instruments here on Earth, telescopes mostly, right? Different flavors of telescopes. So, in the movie Armageddon, there was, of course, a killer asteroid headed for Earth. So they had to send our stars up in a space shuttle that had to do all sorts of things to get there, but they got there. And then their intent was to blow it up with nuclear weapons, right? A bunch of small asteroids will burn up, a big asteroid will not. So that's why it's called a planet killer. Okay, it's a real threat, right? That's why we have near-Earth asteroids, or whatever the program is called. We have NASA and other bodies tracking them, so we'll at least have some warning in case we may be able to do something. For the first time, we have done a test to try and do something. We sent a little spaceship up there. Fortunately, it's only 7 million miles away, 28 times the distance from the Earth to the Moon. The Moon is about 250,000 miles away. We sent a little rocket up there with the sole objective of just smashing into that asteroid, the orbiting asteroid, to try and change its trajectory. Just to see, one, if we could, two, what we can learn from it, because the makeup of the asteroid matters. If it's a mushy asteroid, and your rocket goes through it, and it absorbs the energy but doesn't change the trajectory, that's good information to have if that happens. Now, mushy, of course, is a relative term. Anyone jump down from a 30-foot high dive? Ever? You think order is soft. Once you jump down from that 30-foot high dive, you will discover it's not. It's not as soft as you think. Okay? Same thing here. But they can also, from the ejecta is that which flies off the asteroid after the impact, they can spectroscopically tell the likely makeup, at least of the surface of the asteroid. Okay. Why do I tell you all this? Right. One, because it's cool, right? But two, 7 million miles away, anybody want to guess what the time delay is? The light speed delay.
1 hour.
No. It's about 40 seconds. I did the calculations in my head driving to work or away from work one day this week, right? Because I knew I needed to know that to tell you. It's about 40 seconds. The upshot is, if you're playing a video game, if you have a 40-second delay, you're not going to be very effective at guiding whatever you are in that video game. Same thing with the spacecraft headed for this. What that means is it could not be guided from Earth, which means, and here's the real point, a program had to be written and installed on the spacecraft. Let's do my wonderful art skills again. On the spacecraft to guide it into this tiny little asteroid circling the bigger asteroid. Because seen from Earth, or seen from the cameras on the spacecraft anyway, because they're not the big telescopes we have, there's only so much they can send. This was 1 pixel, right, for the longest time. Anybody know what a pixel is? A pixel, let's talk about these things, not your phones. Phones are a special case, right? A pixel is simply a 1 by 1 smallest unit of display. Okay? Your screen is made up of a bunch of pixels. And they say your display is 1920 by 600 or whatever they say. That's pixel by pixel. That's how many pixels it can contain. Okay? This thing from the camera on the spaceship was 1 pixel for most of the journey. Obviously, as it got really close, it became 2, then 3, then a whole lot of pixels. Okay? But a program had to be written to 1, isolate this guy to make sure it was heading at the right thing, and then 2, control the thrusters of the rocket, just the guidance thrusters, to hit the asteroid. That's computer programming. That's a real life use of computer programming that matters. They were trying to do that when they landed Apollo 11 on the moon. I told you last week or the week before. Computer choked. Too much input, can't process it. Neil Armstrong had to take the controls and eyeball it. Thank goodness he did. He was headed for a big boulder on the moon. So he eyeballed it, went around the boulder and landed. Okay. They didn't have that luxury here because the 40-second time delay would not allow somebody on Earth to correct it. In fact, 2.5 minutes before it was supposed to get there, the systems on Earth, everybody took their hands away from them. They said, it's in that program's hands now. Nothing they could do. They weren't doing much anyway, right? Because the program was doing the job correctly. They were just carefully monitoring it in case there was something they could do. 2.5 minutes before impact, they took their hands off the control saying, nothing we can do. Good luck. And it hit it exactly where it intended to hit it. Now it's going to take a while, revolutions of this little asteroid around a big asteroid, to determine the effectiveness of the test. Double asteroid, it's called double asteroid, redirection test. We're just trying to redirect this thing. And not a lot, just a little. But you can detect it. You can detect small changes in orbits. So this is for when we find a planet killer headed our way, which one day we might. We may be able to do something, because the farther away you find it, the smaller redirection you need. Because that redirection, if it's just a slight degree, multiplies over time and misses your planet, right? So that we don't give it back to the dinosaurs or whatever follows us. We took it from the dinosaurs. We didn't take it from the dinosaurs. We evolved after the dinosaurs because there was a dinosaur killer in the Yucatan, as best as we can tell. Okay? Computers matter. So as you go through your life, right, driving your Tesla, or driving whenever you're driving, that might start buzzing when you cross a line, right? When you're at the DMV renewing your license, when you're talking on your smartphone, think about how computers are used in your life. They really permeate our life. Who's been at a Target and they said, we can't sell you anything because our computers are down. It's terrifying, right? To Target, because Target's losing a lot of money minute by minute. So, okay. So that's your piece of information for tonight to think about. Class info, 10-5, exam 2, a week from tonight. Implicit homework. Never forget the implicit homework. If you've been doing it all along, exam 2 shouldn't be a problem. If you haven't been, exam 2 probably will be a problem. Tonight we're going to talk about topics for exam 2, the few topics we have left for exam 2. We're then going to do the review for exam 2, and then after that, we'll have lab periods of course, and after all that, we'll start on topics for the next section. These happen to be the remaining topics for exam 2, and of course, everything from the start of class up to what we cover. And then we'll start on these topics. We'll see how far we get. Question? Okay. Operator precedence. 7 million miles. Presumably some of you know the speed of light. 186,000 miles a second, more or less. 7 million miles, 186,000 miles per second. Figure out how I got about 40 seconds in your copious spare time outside of class. I can do it in my head. 186 times 4 is about 7,200. Add 2 more zeros, you get to 7 million. Add 1 more zero, you get to 7 million. That's how you get to 40 seconds. Or it may have been 400 seconds. I don't remember, but you can calculate. Operator precedence. For the most part, forget about operator precedence. Okay? Use parentheses. For instance, there are things like multiplication precedes addition. So, multiplication takes precedence. So 3 times 4 actually becomes 12, and then the 5 is added and you get 17. That's just a convention, a mathematical convention for a very long time. But if you wanted to do something else, all you got to do is use parentheses. Then that 4 plus 5 is going to occur first. The lesson I want you to take away from this class is if you want to learn about operator precedence, you'll read all you want, fine and well. I have no problem with it. But in this class and in your programming life, use parentheses for everything, whether the precedence requires them or not. Why? Because it makes it clear what you're doing. Your code is self-documenting. There's no questions about what's going on. What I'm going to say about operator precedence. If you want to learn the details of operator precedence, you can look it up. But use parentheses. The question doesn't arise. I may have said that before. I don't remember. But I said it just in case I had it. Enum in switch. So, let me see how to ask this question. What type is an enum? That's not a good question. What is the representation of all enum type variables? Okay, let's do it by example. We're just going to pretend we have a 3 this week. What is the value of sun in this enum? Yes, enums are integers, but let's back up. What would the integer be for Sunday? When you do not give it explicit numbers, where do they start at? Next. When you don't give it an explicit number, where do they start at?
Would it be 0?
It would be 0. Therefore, what does the next one get? What does the next one get? 2. So you were correct when you said an enum is really an integer type. It gives us a convenient way of expressing things in readable form, but it's really an integer. Now then, back when we talked about switch statements, if you'll recall, this has to be what kind of value? What type of value?
Oh,
An integer, a float,
integer.
a double.
Or a numeric type or integer.
It has to be some flavor of integer. Let's move on. What are a couple of flavors of integer? We already did one, int. That we review all the time. We already did int. What's another flavor of integer? Long, which is twice the number of bits. That's another flavor of integer. What's another flavor of integer? Here's the key one we got to that's important. This is something that you should know, should be easy. If you don't, it would be bad for you on this. Short. short is certainly an integer in most languages. I don't recall if it is in C. I think it is. Short, if it exists, is half the size of an int. What's another type of int? Okay, it is a byte. There's no name called byte in C. What's the same size as a byte? Remember, we said a char is a doubly short integer, and chars are integer type variables. So, what that means is, and hopefully you guys have done your labs and your homework so you understood this, because you had to have done this, you can say, and it will stop on this case. What should I put after, if this is all I want the case to do, what's the next line I should put? And so on. Right? So, this has to be an integer expression in C, not talking about other languages. Other languages have a little more flexibility. But in C, it has to be an integer expression of some sort. And since a character is a form of an integer expression, you can switch on a character. That all makes sense, I hope. Okay, now to the point we were at. Enums. What are enums really? What type are they underneath? It's a numeric type. What kind of numeric type? The values go from this if you don't specify values. The only values you can specify, if you're trying to specify a value, and be integers. For some reason, when it could be 17 for whatever programming purposes. So, an enum is really what type? An integer, right? It just has some convenient, wordable way to express the integer. So what that means is, let's suppose you have that enum, days, and let's just suppose we declare an enum, days, and give it a name, days with a lowercase. Why can I do that? I have this called days, and this called days with simply the first character being lowercase instead of uppercase. Why can't I do that? No, this is perfectly valid. This compiles and runs and everything. It's great. Why can I have days with a capital D as an enum type, and then declare a variable with the same name except lowercase d? Days with a capital D, which is an enum type, and the variable name be days with a lowercase d.
Because C is it's a case language, so it's a significant name.
Exactly right. It's a case language. Days and days are completely different identifiers. Case language. Plenty of people got that wrong on the first exam. Plenty of people will probably still get that wrong on the second exam now. Hopefully everybody's listening. Case language. Okay, back to the point we were really getting at. Suppose I declare this variable, lowercase days, I assign it Wednesday, which is all perfectly valid. And then I say, is that going to be valid, this switch statement? Nope, that's perfectly fine. Okay. The break just says, exit the switch statement. That's all break says. Who's next? Next. Is this valid or not? If it is not case Sunday, then everything else is the default. In other words, is that your final answer? This is good, or do you want to change it to this might have an error? That's the right answer. You can't see any, right? That is the beginning of knowledge. And then you stop and you pause and you say, okay, let me go back and look again. Do I see any? The answer is, I don't think there's any, but I'm not completely positive about this syntax right here. I'm going to have to check it, but I'm pretty sure that's correct, right? Because ultimately, switch has to have an integer expression. We've already determined that enumerations are integers. I declared an enumeration. I assigned it Wednesday. Oh, and by the way, let's suppose I didn't assign it anything. A little comment there goes a long way. If I just declare it and don't assign it anything, what do you think it's initialized to?
0.
The answer is, I'm not sure, right? I seem to recall reading something that said it was initialized to 0, but in general, nothing is initialized to anything in C. So I'll have to look that up. Right? And I'll give you that answer after the first break.
I think it's like, it just gets pointed to random garbage data, right?
That's the other choice. It's either initialized to 0, or it's not initialized at all, and whatever was laying in that memory is there. I will look up the answer and give it to you. But I think this is the case where it initializes it to 0. But the rest of this is perfectly valid. I'll have to look up this syntax to make sure. But the rest of this is valid. The point being, you can use enumerations in switch statements, because enumerations are just another way of expressing integers. It's a convenient way that makes your program make sense. Unfortunately, there's no convenient way to get this name output in C. In all the other languages, in most of the other languages, there may be one I'm not thinking of, it is. There's ways to get the string value of this thing easily, okay? But not in C. I did look that up ferociously. I feel like I couldn't believe it, but then I thought to myself, okay, it is C. You can use enumerations in a switch statement. Again, implicit homework. Look it up. Write little programs in the online C compiler I showed you, just to see how things work. Because that's how I want to test this. I want to test this. I'm just going to type it into the little online C compiler and see what happens. Although I'm pretty sure it'll work, I'm not positive it'll work. Okay, any questions about enums in general, or enums used in switch statements? Speaking of this, there's lots of things that happen like this. When SpaceX sends a ship up, be it a cargo ship or be it a manned ship, dock with the space station, nobody's hands on the control. Their hands are right over the control in case they need to immediately take it and back up, right? But the computer docks it. The computer docks it all by itself. Another use of computers that we didn't used to be able to do. We used to have to do it by hand, where a guy had his hand on the controls. And you guys have played video games, you know, you should find a lunar lander video game, see if you can land it. It's pretty funny to try. Well, funny is one word. Frustrating is the actual word. Okay. Oh, sorry. Question?
The example of the switch statement with the minute, is that only works if days has the same case throughout all of them, right? Is that the first days and the versus enum days is capital? If we wrote that exactly in our code, it would have an error or not?
This right here?
The one before it.
I mean, this line?
Yeah, on that line.
That gets the syntax error? No. This I know will not get a syntax error. What I have to see is if this is the right way to express this case. I think it is. The reason I'm confused is because I know it's not in certain other languages. That's why between C#, C, C++, JavaScript, TypeScript, all of which I use regularly, I sometimes forget what goes with what. In C#, no, that won't fly. C++, I don't think this will fly. I'll have to look. JavaScript, this will not fly, sir.
Do you need to have the semicolon after the comment or something?
No. I just had it there in case I wanted to very conveniently assign ways to do it. Right? After the two double slashes, everything to the end of the line is a comment. To the end of the line, or a double slash. In other words, I could put slash, slash, equal, so whatever. I put anything, right? Anything to the end of the line, treat it as a comment. I'm also monitoring my daughter's flight from Denver to Baltimore with her children. Well, you never stop being a parent once you become a parent. I'm not bothering her, I'm just, we have the tools. You have FlightAway, you can track a flight. What a great use of a computer in everyday life. Think about uses of computers in everyday life. For your generation, they are endemic. Endemic means everywhere, all the time, not a problem. Right? Like the flu is endemic. COVID was a pandemic, but it is becoming endemic in the sense that most people are vaccinated and or the variants are less lethal, just like the flu. Right? That's what endemic means. For you guys, computers are endemic. They're in everything you do. They're in your phones, they're in your laptops, they're in your tablets, they're in your cars. Anybody know why there was a problem with cars? Because of supply lines? They couldn't get chips for the cars. What did the chips control in cars and trucks? They controlled engine firing very closely, and that's how they met EPA emission standards, right? So they couldn't get chips, so they either couldn't build those vehicles, or they couldn't sell them in certain places like California, who has more rigorous emission standards for vehicles than other states. So that's what they did. They kept building them the amount they could sell in other states. Fortunately, the chip supply has eased up. Okay. But they are everywhere. Computers are everywhere. Okay. Pointer arithmetic. No magic here. Arithmetic is simply plus, minus, times, divide, right? Addition, subtraction, multiplication, division. The reason that you need to do pointer arithmetic is that you have to make your pointer point at the right piece of memory to get what you need to get. How would I allocate a piece of memory to represent 4 integers? We went over this last week, I think. Address. There was a particular function you had to call. And then you had to give it some parameters. The function name should be easy. The parameters are what's the challenge. Who knows what the function name is? What's the function name?
Mallet.
Mallet. What does the M in mallet stand for? Memory. What is alloc the shortened form of? Allocation. Okay. So you call mallet and you pass it some parameters. In particular, the number of bytes. So, how do we know how many bytes? And remember, we want to allocate 4 integer array. I just picked 4 out of the air. Doesn't matter. So don't worry about the 4. How do we know how many bytes to allocate? If I say 4, how many bytes are going to be allocated? 4. How big is an integer? So let's change this to 6. So if I just put 6 here, I'm going to get 6 characters, 6 bytes allocated of memory. Will that hold 6 integers? 6 bytes. Will it hold 6 integers? 6 ints. No, it's not an array. Will 6 bytes be enough memory to contain 4 ints?
Oh, no.
Okay, that's correct, it will not. So how do we tell it? How do we change this to be able to figure out the right number of bytes to contain 4 ints?
Multiply by 4.
Okay. If on your machine the size of an integer is 4 bytes, that would be correct. How do you know for sure what the size is on your machine?
Size of?
There you go. Takes all the guesswork out of it. 6, which is the number of integers I want allocated, times the size of an int. Boom, you get a piece of memory. And that pointer points to it. Sir?
I have a question. So like an int is 4 bytes, right? So can you do like 6 times 4 and just have like 24 bytes allocated in a sense?
You could, but it might run wrong. Not all machines have an integer size of 4 bytes. There are machines that have an integer size of 8 bytes. In fact, native 64-bit machines, outside of the C definition, they treat it as 64 bits, i.e. 8 bytes. So you might be correct, but why take the chance? Just do that. Because the compiler, there's no runtime penalty. The compiler converts this to 4 or 8 or whatever is the right thing for that machine. Sir?
How do you know that the integer inside the size not correct is just going to be the integer with the capital I?
There is no integer with a capital I. That's a variable name. As someone adroitly pointed out, it's a case language. All reserved words are lowercase. There may be 1 or 2 exceptions, I'm not remembering, but all reserved words are lowercase. Int, float, long, short, whatever, all lowercase, and they're all reserved words. In other words, you can't say declare a float type variable and call it lowercase int. The compiler would give you an error saying that's a reserved word, you can't use it like that. I'm pretty sure the compiler would give you that error. Okay.
Can you give an example of where that thing would be used?
Sure. You start a program that says, give me the number of students you want to enter. And it's a variable that they type in. And you do scanf, %f, or %d into a variable, ampersand of type int, called number of students. And then that's how many students you're going to deal with. So you want to allocate an array with whatever size they entered. That's how you do that. This is the best way to do that. I mean, there are other ways to do it. For instance, if they entered that into a variable, suppose you had a variable in students. There's a thing called Polish notation that says precede names with a type specifier. N was the thing for an integer because it's a number. That's just something frequently used. Frequently you'll see in old C programs. But then you say scanf, %d, ampersand, in students, and they give you the number of students. Okay? You could also then say int, just to follow the naming convention I had up here, and to point out the uppercase I means it's going to be a variable. The uppercase I does not mean it's a variable. The uppercase I says it is not lowercase I. That also declares that variable size of an array. But it might not be that simple. That's why this is the preferred way of doing it. Because if you'll remember from last week, if I allocated this, how would I reference the third, i.e. index 2, integer in that array? Pn. So there's a number of ways I could do it. Let's do the easy way first. That is correct. That will give you the third entry, 0, 1, 2. Array started 0. All indexes started at index 0. Okay? So if I allocated this, pint of 2, treat pint just like an array. You can treat any pointer just like an array, assuming you do it correctly. And boom, you get the end. Now let's go to the other thing he was talking about. So let's suppose we don't want to lose the reference to the original allocation. Let's say int pointer p new is equal to pint. That just means that p new points to the same place as pint points to. Because remember, a pointer contains a memory address. Take that memory address and stick it somewhere else and then use it just like I could in the original case. So I allocate another pointer called p new and I assign it the value of what is in pint. Hasn't moved any data. Question?
So is the memory address just a starting point of the bytes that are allocated, or does it specifically contain the list of all the memory locations that are allocated? Because if it just contains the...
One question at a time.
Okay.
Your first question is, when you say memory address, remember, do you mean a pointer?
Yeah.
Okay, a pointer contains a memory location. That is all it contains.
But is it size dependent? Like, is it possible for it to contain a larger or smaller amount of memory? Because when you allocate that memory, that doesn't
It
necessarily...
does not contain any memory. It contains a pointer to memory. Okay, let me draw another picture. Suppose pint contains the value 44. Over here in another chunk of memory that starts at 0 and goes to, a big number, 20 megabytes, let's say, whatever it goes to, okay? And remember, it's contiguous. We draw it like this just for convenience, okay? So let's suppose this is integer 40, address 40, this is address 41. So address 44 is going to point to a piece of memory. That's all a pointer is. It simply contains the memory address in some other piece of chip block memory of where it's actually pointing to. If you stand out in the parking lot and point to a car, your arm is not the car. It is simply pointing to the car. And can be used by the cop to say, that's my car that won't stop. Can you please give me a jump? That's a pointer. That's all a pointer is. It's a memory address. It does not contain any memory itself. The memory address it points to, that piece of memory contains whatever it contains. An integer array, a byte array, a character array, a float array. It contains whatever is meaningful to typically the pointer type. We'll get to that more in pointer arithmetic. But that is what a pointer is. You have to wrap your head around what a pointer is. If it helps for me to say the pointer is your arm pointing to the car, so you have a car pointer, that's your arm, but it's not the actual car, it's just pointing to where the car is. That helps you? Okay, maybe that'll help some people. I hope so. This is crucial to everything you're going to do for the rest, most of the rest of the class. All these other concepts are important too, because you have to have those down too. But pointers and this dynamic memory allocation is how everything ends up getting written. Okay, back to his question. Okay, so we did the simple way by using the index. Let's suppose, whoops, I erased my pointer. So I made a copy of the memory address in p new. So suppose I say p new plus equal 1. First of all, who's next? What does that do? No, it says plus equal. You have to know what these operators do. What is plus equal equivalent to? P new is equal to P new plus 1, right? Two different ways to say the same thing. P new plus plus, another way to say the same thing, as long as this is only 1. Okay? You guys will need to know all this for every exam going forward, actually for the past exam. So, I've incremented p new plus 1. So, int y is equal to p new sub 0. Let's say p new. Let's use the same index we used up here. P new sub 2. Will x and y contain the same values? Remember, I've incremented p new by 1. I've moved the pointer. If I move the pointer, is it pointing at the same thing or something different? Something different. So it's unlikely that x and y are going to have the same value. By happenstance they might, but they're not pointing to the same thing. Okay, now here's the wrinkle. When it said p new plus equal 1, the compiler interpreted it because the compiler knows that p new is of type integer. The compiler knows what the size of an int is. In most cases 4, as you said, but not necessarily. But the compiler absolutely knows. So actually, it moves this pointer 1 type size. So it actually moves it 4 bytes in the cases of most integers. So that the indexing works correctly and the pointer arithmetic works correctly. So you add 1 to the pointer, it moves to the next element, whatever the element size is. Element being integer, float, char, whatever it is. Hopefully you guys are beginning to understand why I cannot teach you all of this in this class. Right? I can give you this, you have to go home and do that implicit homework to truly understand it. So that's pointer arithmetic. You can move pointers by adding, you can move them by multiplying if you want to. You can move the pointer by doing arithmetic on it. You can move it forwards, you can move it backwards, whatever. But you have to do it correctly. You have to do it within the bounds of what you've allocated. We allocated 6 integers. So just like if I change this to say 10 sub 10, the compiler's not going to say anything. Why? Because the compiler doesn't know. This 6 may have been a variable. So the compiler doesn't know at compile time what it's going to be. Could be 12, could be 6, could be 2, could be anything, right? But you committed an invalid index that it will give you whatever's laying in memory at that place. That's what it'll do. And assign it to the variable x. But it'll be wrong, because your program's wrong. So you have to do it within the bounds of what you've already allocated and allowed for. So for instance, one of the things you will commonly see in programs you'll allocate some number of integers in an array. Suppose we just put the word count in here. You guys know you have an exam next week, so I'm erasing that for the moment. There's a very fast way in C to initialize an array to 0. You assign a count to 10, you allocate the array, that count times the size of int, get the array allocated, and then you put this loop in. For the initialization statement, you create a new pointer called p new, you assign it to pint, which you allocated up here via the malloc. You go until while count is greater than 0, and then you decrement p new. You increment p new. So p new points to the next integer in that array on every iteration. And then it assigns p new equal to 0 and it decrements count.
Can we decrement count in the for loop on the rightmost side next to p new? Like, what would be the notation to add another requirement?
Yeah, that can be an expression. I don't think you can do that.
Okay.
But again, this ends up doing the same thing. I don't remember if you can put multiple statements separated by semicolons there. I do not think that you can.
Okay,
You can
thank you.
put a single statement. But I'll look it up and let you know. But for now, for the purposes of pointer arithmetic, which is what we're really talking about, this is a very fast way to assign 0 to all of those integers in the array. The point of this is for you to understand pointer arithmetic and how it moves, how you move pointers. First of all, you have to understand what pointers are and what their really purpose is. It's pointing at something. It's not the thing itself. It's just pointing at something. And that's how pointer arithmetic works. Sir?
Why are there semicolons between P, U, count, as well as
Semicolon where?
and different
Here?
on top?
Yeah. Syntax of a for statement.
Sorry.
Syntax of a for statement. Initialization, condition, and typically increment or decrement. That's the syntax of a for statement. Implicit homework. Look it up carefully. Sir?
What do you have written right after malloc?
Oh, okay. Malloc, it says malloc, parenthesis, count, the variable I declared right above it, times size of int. Just like this. Except it has count instead of the hard-coded 6. Look up pointer arithmetic in your books, in Google, in your references, whatever you want to look it up, and understand how it works. To understand pointer arithmetic, the prerequisite is understanding a pointer, and what a pointer is and what it does. That it points to memory, it points to something, it is not the something itself. In many cases it points to an int, it is not the int itself.
So in the line p new 0 equals 0, are you just setting the same reference, the same place to 0, the integer 0 over and over again?
Nope. And there's why. Because
Okay.
every time through the loop, it executes that statement. Well, it does the condition check, count greater than 0 first, and then if everything's good, it executes that statement, which is incrementing that pointer, doing pointer arithmetic. This is p new plus equal 1, or p new is equal to p new plus 1. And the compiler automatically generates the code to know that it has to multiply 1 times the size of an integer. But the compiler automatically does that because it knows it's an integer pointer. If it was a character pointer, it would not do that multiplication. Character pointers are by 1. Actually, on most machines now, characters are 2 bytes.
And you only need to put the asterisk when you're declaring a pointer?
So, we're going to get to some other pointer things eventually. But to declare a pointer, yes, you use the asterisk. Use it in front of the name. The reason it's done biased towards in front of the name rather than biased towards the type is because of some other funny things in C where you can declare variables of that type and also pointers, which we'll get to when we talk about structures. Unfortunately, it's like enum, where the type of the enum and the enum variable at the same time. But that's just the way the language was. Because they were trying to save space. They weren't only trying to save space in running memory, they were trying to save space for the input that the compiler was going to operate on. The memories, computers didn't have much memory. Memories were small. So they were trying to save space in all sorts of ways. We no longer have that problem, but we're left with some of the remnants of what it causes. All right, that's pointer arithmetic. Study it, look it up, read it. It's not a simple subject, if you're new to it. And you have to do lots of examples of your own creation. But in that, well, I mean, the books will have examples and things like that. But reading the example is one thing. Putting the example into that online compiler and running it and seeing how it works and looking at various values as it executes, that's how you really learn. Okay. Any other questions about pointer arithmetic?
So if you were to change that integer x to 2 again, where it says 10, int x equals p int 10.
Over here?
Yeah, that one up there. If you were to change that to 2,
This one?
yeah, that means it's pointing at whatever the third value is in the array.
Yes.
And then if you add 1 to the new pointer that you declared, is it going to move to the fourth value in the array?
No, because I haven't moved pint. I've just used pint to index it. I have not moved pint. This does not move pint. This just makes a copy of pint and pnew. This does not move it. This is indexing an array, referencing an array. It's saying go to the third element, which happens to be index 2, and get the value out, or put it right there. That's all it does. When I do this, it is now pointing at index 1, because I added this 1 here. Sit down, do examples, practice. One way to understand it. Okay, last topic on pointers and pointer arithmetic for now. Okay, well, let's suppose, once again, you allocate a pointer called pint to a piece of memory you've allocated with malloc that happens to be 6 times the size of an integer, so it can hold 6 integers. So we talked about pointer arithmetic, where you can assign, you can make a copy of that pointer just by declaring a variable and assigning it to it. You've made a copy. We've also talked about how you can reference a piece of that memory by using an index to it. You can also reference a piece of that memory by dereferencing the pointer. You dereference the pointer by preceding the pointer with the asterisk character. That's what dereference means. These two statements are functionally the same thing. You don't necessarily will understand all of this, but if you take notes and write it down and then do your implicit homework and study it and put it into programs and see what happens, you may come to understand it. So pnew++, we assign pnew as a copy of pint. Pnew++ now is incremented. So this malloc, let's suppose it allocated a chunk of memory right here. Because this is an integer array, it will logically be like that. So pint, remember, is a pointer, and that is what it points to. The beginning of the memory we allocated. Hopefully that's logical. You get the next question. So we've incremented, we've assigned pnew to be a copy of pint. we've incremented p new by 1, p new plus plus. Where does p new point to in this piece of memory? Did you say 5?
Yeah.
Why would it, here, why would it point to 5? Did I increment it by 5? No, I assigned some variables, I assigned p sub 0. This happens to contain 5. But this p new plus plus, where does that make p new point to?
1.
That's right. P new points to there. So where does p new sub 0 point to? In other words, using it as an array and indexing 0. Where does p new sub 0 point to? Points to here. This resets it to 0. It doesn't reset it to 0. That says go to wherever p new is pointing, move 0 down from it, and reference that.
So it'd be 1.
So it would point to the same place. Where does p new sub 1 point to? Here comes a curveball. Where does p new sub 3 point to?
4.
That's right. So maybe if everyone is furiously writing this down in your notes, and then you go home and study it and try programs, you'll come to understand this.
So if you wanted to access the old p new 0, which was 5, could you do p new -1?
You could. Yes, you could. So I had to run the compiler that exists in my head to make sure. And yes, you could.
Is it saying that piece of p new 0 is starting at 1 now? That's the starting point.
That's correct. That's exactly correct. I love it when little light bulbs go off. It's a happy thing. So hopefully this further explanation will help with pictures. Someone said they watched YouTube videos to learn about the language. Never watch YouTube videos to try and learn a language. You watch YouTube videos, learn how to pour concrete. It will do more harm than good in trying to learn anything about programming. I've watched a lot of them in hopes that it would, but it doesn't. Worse, I've seen the results when people do. It tends to confuse them more than clarify them. In other words, if the book cannot get you to understand it, it is guaranteed that a YouTube video will not. Writing programs and running programs, that will help you, because you will come to understand what happens to the variables. Use lots of scanfs and printfs to get variables in and out. You will come to understand what's happening. It's time. There's no way to not pay your dues in this program. You've got to pay your dues. Your dues are simply learning how to program by programming. No other way. The real point I was trying to get to here was this one about dereferencing a pointer, which says access the memory address that the pointer is pointing to and do something to that memory address. Do something to the location at that memory address. So it says pint is a memory address. The dereference of the asterisk character says go to that piece of memory pointed to by pint and do this, whatever this is. In this case, it's assigned 5. That's what the dereference operator does. You can think of the dereference operator as the opposite of which operator? Who knows? The ampersand, which is the reference operator. The dereference operator is the opposite of the reference operator. The reference operator says, take this variable and get me a reference to it. That's what the reference operator does, and creates a pointer. The reference operator is the asterisk, or the star as some people call it. I star more often than anything else. The ampersand is the opposite and is the reference operator.
So when you declare a pointer variable and you put the star there, are you also using the dereference operator?
No,
Okay.
that is the type. So in other words, when I say like this, int, this says pointer. When you're doing it after a type, you're saying make it a pointer of this type. That's why, because I never declare multiple variables on the same line, I in fact always write it like this, integer pointer. But more correctly, it is written like this. It compiles correctly either way, in single declaration.
When you use the asterisk p in when you're dereferencing, yeah, does that set in the memory allocation? Does that set all of the values to 5 or just the value of 0?
Just what this is pointing to.
Okay. Yeah.
So pint points to here, and it knows that pint is a type integer, right? It's an integer pointer. So it says, for the memory starting at here, for the pointer, for the size of the type of the pointer, which is an integer, put in 5. So that's why you get 5 right there. These two statements do the same thing. Study it, practice it, write little programs. All right, I'm going to cover one quick topic called methods before we review for exam 2, which is the beginning of next week. But methods will not be on exam 2. I'll go ahead and cover it to make sure it's covered. And it's a relatively quick topic. The basics of it, which is what I want to cover now real quick. Okay. A method and a function are the same thing. Interchangeable words, right? For our purposes. In later languages, a function will come to mean something in particular. But for our purposes, a method and a function, the two words are used interchangeably. Okay? So let's talk about a function. We talked about this at the beginning of class, not this one, sorry, at the beginning of the course, when we talked about a signature. If you look back in your notes, you will see something like that, where a method declaration will not say this. This is an addition in the body of the function. It is a type, it is a function name, which is just like a variable name in terms of its what it can be, and a parameter list. Go back and look at your notes, that's what we talked about. So, let's do a simple example. Int my method paren, so the parameter list can be empty, but the parens are required. The parentheses right here are required. The parameter list can be empty. We'll move on to non-empty parameter list in a moment. And then you have the body of your method. You can declare variables in it, and then you can say return X. So when you say return X, the value of X is returned to the caller. We'll get to the caller in a minute. But this is how a function works. Give it whatever name you want to give it, as long as it follows the naming parameters. You can't start with a number, start with a letter or an underscore. You can have almost anything after it, except dashes, except special characters. It's largely limited to characters and underscores. And then it does whatever you want it to do. So that's a simple case of a function. So when this says body, what a body can actually be is a single statement. Never do that. Remember I said always use braces, all for the same reasons. But technically, it can be a single statement. It can be a compound statement. Or it can just be a semicolon. If it is just a semicolon, you are declaring the signature of the function, but not the body of the function. We'll talk more about a special case, not a special case, we'll talk more about the case of a semicolon later when we talk about header files. We talked about them a little bit, not anything that you're going to be tested on yet. Okay? But typically the body is braces with statements inside of it, like this. So to continue on with this function, with this method, you guys have been using methods all along. You've just been using the special case of main, which is where every C program starts. You've been using methods all along. But what you really want to do is to modularize your program to put it in small pieces that are more easily understood. So let's suppose you just declare an integer variable called getValue. And you can call the method myMethod. Now because myMethod returns an integer, you can assign whatever is returned from myMethod to some integer you declared, called getValue. And when it comes back, what value do you think getValue will have in this scenario? What will the value of getValue be? 3. Because you assigned 3 to x, you returned x. So 3 came back out of this method. 3 got assigned to getValue, and that's the value of getValue at this point. Okay, let's suppose I change my method to actually take a parameter. Let's suppose that parameter is called decision, and it's of type integer. And let's suppose I change this code to say and then suppose I called my method with a value of 13. So suppose I change my method, take a parameter event called decision, and I put this code in here. If decision is equal 3, then return 10. And if not, it will continue on and return 20. So if I call my method with a value of 13, what is getValue going to end up getting assigned? Is 13 equal to 3? No. So it will not execute that because this is false. So then it will come on down and execute return 20. So it will return 20 for the integer value and assign 20 to getValue. Right? Because this if statement was false. Because this is false, it does not execute the body of the if statement, and then simply continues executing.
Wouldn't you need a break, otherwise it would just return 20 anyway?
Yes, it will return 20 in all cases where decision is not equal to 3.
What he's asking, so return exits the method the same way that break statement would exit the method?
No.
Oh, then why
Break
doesn't
simply stops executing a loop,
then why
or in
doesn't
the
it,
case of the switch. Return says return whatever the value is you're returning.
I think what they're asking is because it's not an else after the if, wouldn't it just like, so if it is equal to 3, it returns 10, but then since it runs again at return 20, doesn't it just return 20 always?
It returns, yes, you could have said else, return 20. That would have been valid too and done the same thing. Most programs can be written in multiple ways, but you are correct. You could have put else, return 20. and it would have done exactly the same thing.
I think at least I'm confused, I don't know if they're confused, is, for example, if instead of saying return 10, you said like some variable x equals 10, and then you said some variable, let's say x equals 20 in that case?
And then it said return x?
Well, not return x. Well, you could say return x at the bottom. It would return 20 either way because there's no...
It returns whatever you put inside the parentheses.
Right, but...
That's what it returns. Simple as that.
There's two return statements, but there's no like deciding factor on which one to use.
It is. If decision is equal to 3, then return 10.
But why does it stop at return 10 if there's no...
Because that's the, I get your question now. That's the definition of return.
Okay.
It returns this value and exits the method. Sorry, that's a good point. I understand this question now. Return says, assign this value as the result of the function and exit the function. Sorry, that's what return, yeah, I didn't define return. You're right. That's what return does.
And how do you know that it sets it to get value?
Because I said, whatever comes out of my method, assign it to get value. It's just the syntax of the language. Assignment statement, the left side is what gets assigned. The right side is what the value that's assigned to the left side. That's all there really is to methods. I mean, we'll get more complicated with more parameters. I doubt we'll get to a variable number of parameters in this class. But you can have multiple parameters. In this case, we don't, because we defined it to have a single parameter of type int. But that's how methods are. Methods, functions, same thing. Implicit homework. Go read about methods and functions and parameters and write programs using them. In fact, you have a lab or a program that requires you to do so. It's either coming up or the next week or two. Okay. By convention, what is the terminating character of a string ABC? By convention.
S. S.
Nope. That's the format specifier that scanf would use to input a string, or printf would use to output a string. What terminates a string?
Are you talking about like, in the byte representation gets terminated by a null byte?
By a null, that's correct. What is the escape sequence for the null character? Escape sequence for the null character.
\0.
\0. \0 is the null character that terminates strings. Compiler mostly puts it in for you, but not always. How do you terminate a loop? A for loop, a while loop, or a do while loop? How do you terminate a loop or exit the loop? Other than with the conditions. How would you exit it without using the conditions?
You could use break, or you could like set a condition to exit.
Break. Break is how you exit a loop outside of using the condition. I mean, if the condition exits the loop too, that's fine. But inside the loop, keyword break is what you use. What's a way to stop that iteration of the loop and continue on to the next iteration of the loop? What keyword is used for that? Continue. That stops that iteration and moves to the next iteration. It does not exit the loop, it simply stops that iteration of the loop. What's one of the components of the three components in a for loop? What is one of the components? You can pick any of the three.
In a for loop.
In a for loop, yes. In other words,
Initialization.
we have this. So we have these three things. So you can pick any of the three.
Initialization.
And which one is it?
The first one.
This one, okay. Initialization. Okay, next person, you get to pick one of the other two, either one. That is correct. It can actually be any statement, but it's officially referred to as the increment. Okay, for statement. First part is initialization, the last part is increment, what's the middle part? Addition. Okay, that's the for loop. Any questions about the for loop? And the three components of the for loop statement? Right over here. And a switch statement. What kind of value has to go here? It is an integer value. It doesn't have to be a variable, it could be an expression. It could be some variable int x, you could say int times 3. Perfectly valid, as long as it's an integer expression. All of that. How do you express the parts of the switch statement that are chosen by the integer value?
Can you repeat the question?
This switch chooses something in here based upon this value. Right? What's the first syntactic thing to put for that section to be referenced?
Case.
Case. And then what follows the case?
Whatever the value is equal to.
It is just the value, you're correct. The colon. So after the case, you put statement, statement, statement. What do you put in the case? Because you're going to have another case down here, presumably, or some other value. So what do you put right here to say, I'm done executing this case?
Break.
Break. So you have all these specific cases. What do you put for everything else? In other words, you have case 1, case 2, case 3, so forth. And then you have everything else. What's the key word for that starts with everything else? Default. And then it's the same thing as the rest of it. Any questions about the switch statement?
What if you put a continue before the break?
A continue does nothing for a switch. If there was an enclosing for loop around the switch, that continue would apply to that enclosing loop. But as regards the switch, it does nothing. Continue does nothing. Study all the loops. What are the types of loops? Here, we'll do it that way. What are the types of loops? It is typically referred to as a do while, but it starts with do and has a bunch of stuff in it. Study the loops, how they all work. Right? We talked about for in detail. While and do while are a bit simpler, but not identical to each other. Make sure you understand the difference. When you declare an array, however you declare it, either int with an array index or by a pointer with a malloc, however you declare your array, what is the first index of an array? 0. All arrays start indexing at 0. We already answered this, but let's hit it again. When you're using scanf or printf, what is the format specifier for a string? %s. Understand what pointers are. That pointers are variables, but they are variables that point to memory. There was a question on the last test that talked about that. It contains the memory address of another variable. That is what a pointer is. Right? But you have to understand a little more deeper than that statement. Because you have to understand pointer arithmetic, what pointers are actually pointing to, the type of a pointer that the compiler knows and uses, and incrementing when you do pointer arithmetic. Okay, that is the review for exam 2. At the beginning of class next week, you can ask specific questions. No, show me an example of. No, what's your favorite food? No, specific questions on the material. Okay, rehashing dynamic arrays. Okay, this is the declaration of a dynamic array. You guys want to carry that on in the hall, or you okay? Okay. This is the declaration of a dynamic array. So we've already covered this. The other case that I showed you, I wanted to make sure I didn't gloss over it. If you will recall, we essentially wrote code that said this is also declaring a dynamic array because in students is dynamic because I got input for what the value of in students is. And then I declared the array explicitly by using a variable as for the number of indexes. Okay? That is also a dynamic array. This same code could be written instead of using that statement. This would do the same thing. This would also give me a dynamic array. Because again, in students comes in, that's the number of integers I'm going to put in this array. And I use malloc instead. You like how I continued it on to the next line? And everybody remembers about white space, right? Carriage returns, line, end of line is just like white space, it's just like a space. C compiler doesn't care. But I tell it to give me this number of bytes, the number of students times the size of an n, the number of bytes. These two statements are functionally equivalent. I could then say, students of 3 to get the 4th student. I can say p students of 3, which would all get me the 4 students in the newly allocated array. These are both methods of dynamic array allocation. This one is used much more because it's much more general. There are a few other wrinkles that we don't need to go into it now. I mean, this will throw an exception if it can't get to memory. This just proceeds on blank. But on modern computer systems, that rarely happens. Unless you've made a mistake in the number of n students, like you put 1 million or 1 billion in.
So the first 3 lines is just a different way of writing the other one?
No. The first, okay. The first 2 lines are just getting a value for n students. Okay. The thing circled in black is one way of declaring an array called students. The thing circled in red is just another way of declaring the same kind of array, exactly the same allocation, called p students.
Does it effectively do the same thing, or is there any subtle differences?
There are subtle differences that we're not going to talk about.
So they're not important to this course?
Nope.
Okay.
Only that this would be the preferred way.
Okay.
But they're both declaring dynamic array. By dynamic arrays, we mean the size of the array is dynamic. By the way, dynamic arrays and methods will not be on exam 2, but pointers and pointer arithmetic will be. You have to understand what a pointer does. What it actually points to, what dereferencing a pointer is, what creating a pointer is by using the reference operator. What's the reference operator? Anybody? Ampersand. What's the dereference operator? Star, asterisk. Star and asterisk are the same thing. Shift 8, I think. Yep, Shift 8. You use the reference operator to create a pointer. You use a dereference operator to get at what the pointer is pointing at. So it depends on what you're doing as to which one you want to use. That's why you have to understand what they're for It's not a matter of memorized syntax. That will not help you. It's a matter of understanding what the syntax means and does. Okay, questions? At the beginning of class, everyone will have at least the chance to ask one specific question. Maybe two, depending upon how many we get. Maybe three, depending on how many we get. Okay? Have a nice evening. Please study.